Hello my dear students, welcome back to NEET World. So today in this session we will be discussing the mole concept, okay, the PYQs of mole concept, the content related to this some basic concepts of chemistry and mole concept is already covered in this channel. So just go through this playlist of this channel, okay, you just search some basic concepts of chemistry EAPCET 2026 or JEE NEET 2026, then you will get it as in this channel itself, okay. You can watch all those content, and in this particular session we are going to discuss PYQs from JEE, NEET and EAPCET exams, okay. So right, so look at this first question. Yeah, so if you are started following us, you just see the previous videos. In the last sessions I have covered structure of atom PYQs, okay, and also equilibrium charter PYQs also covered for NEET, JEE and EAPCET exams, okay. Yeah, if you haven't watched them, after completing this session you can go through that once, okay. Right, let's begin the session with the first question. For the formation of 3.4 grams of ammonia, what volumes of hydrogen gas and nitrogen gas respectively required at NTP? See, at STP or NTP they mention any standard conditions here. First of all, write the balanced equation like N2 plus 3H2 gives rise to 2NH3. This is a ammonia formation equations by Haber's process, right? Yeah. So now if you observe, it's a balanced equation where here we required 1 mole of N2, 3 moles of H2 to produce 2 moles of ammonia gas. Now how many grams they have mentioned? 3.4 grams of ammonia gas they are saying. See, 3.4 grams means how many moles it is? 3.4 grams divided by molar mass of ammonia is 17. How much? Molar mass of ammonia. How do you calculate this? NH3 na, so 14 for nitrogen, 3 for hydrogen, so 17. So this will be like 0.2. 17 to the 32, 34, here 3.4 is there, that's why I am writing 0.2. So for producing 2 moles of ammonia, we require 3 moles of hydrogen. Now they are saying us to produce 0.2 moles, okay. So 0.2 moles of ammonia we required now, okay. So in order to get this, that is nothing but 3.4 grams of ammonia is nothing but 0.2 moles of NH3. So this will be coming from 0.3 moles of H2 and 0.3 moles of N2, that's it, okay. Right, now we have written in terms of moles. You need to know that at STP condition, it means at NTP condition here, 1 mole of any gas occupies 22.4 liter volume. What is the volume occupied by 1 mole of any gas? It is 22.4 liters, okay. Now how many moles it is mentioned for H2? It is 0.3 na. So 1 mole occupied 22.4 means 0.3 mole will occupy how much? Okay, it will be X liters. So now X you can calculate by using unitary method, 0.3 into 22.4, okay, that's it. So what is the answer here? So 4 3 is a 12, 1, 6, 7 and 6. So 2 decimal 6.72 liters. So how much volume of H2 required here? 6.72 liters of H2 is required. See, there are two options with 6.72, 6.72 for hydrogen, okay. Now they are asking, this is for what? This is for hydrogen, it is over. Now similarly, can you do it for N2? See, 1 mole of N2 occupies 22.4 liter, okay, but here it is mentioned as just 0.1 it is mentioned, okay. So 0. Will occupy how much? 2.24 liters, that's it now. So here it is 0.1, this should also divided by 10, that means 2.24, okay. So what are the answers? 6.72 liter and 2.24 liters. So option C is your perfect answer for this discussion. Hope the discussion is clear, okay. Is there any confusion in this? Yeah, if there is no confusion, please hit on the like button. If everything is clear, please hit on the like button. Yeah, if there is any confusion, please write in the chat box. We'll discuss it once again. Right. Right, let's move forward. Yeah, look at this question. The average molar mass of chlorine is 35.5 gram per mole. the ratio of Cl35 and Cl37 in naturally occurring chlorine is. See, it's very simple. If you extract the chlorine, the average molar mass of that chlorine is this much. Okay, so if you are extracting 100% chlorine, okay, in this 100% chlorine you are going to have two isotopes. One is Cl35, okay, and one more is Cl37. One more is Cl37. So now what is the molar mass of average molar mass of these two things? 35.5. So let us say the percentage of abundance for the Cl35 is something like, we'll say total is 100 now. So let us say this is x, this will be now 100 minus x. So totally if you sum this total, you are going to get 100%. Okay, it's very simple now. So the average atomic weight is equals to percentage abundance of this 35 Cl. So that is 35 into 100 minus x plus 37 into x. Okay, why I am taking this is x percentage composition now, divided by total abundance, that is 100. Okay, simple. So just average is how much? 35.5 into 100. This is equals to 3500 minus 35x plus 37x. So it will become, so this is 3550 minus 3500. So this will be 2x. Okay, so here it will be 50 equals to 2x, so it will be 25. So now 37 is having x now. What is the x value here? 25. It means 37 isotopes, Cl37 is 25% and 100 minus 25 is 75. So Cl35 is 75. Now they are asking ratio of this Cl35 to Cl37, that is 75 by 25. So it is 3:1. So 3:1 means option 3 is your answer for the question. Okay, right. Let's move forward. Let's move forward. Look at this. How many moles of ammonia produced by 5 moles of hydrogen gas? So how can you do this? How many moles of ammonia produced by 5 moles of hydrogen gas? So just balance the equation first. It is 1, here it is 3, it is 2 here, that's it. Okay, so 3 moles is producing 2 moles of ammonia. Now they are saying 5 moles of H2, 3 moles producing 2 moles as per the equation. Okay, now 5 moles of hydrogen gas is taken, this will be x now. So x can be now 5 into 2 by 3, okay, 10 by 3. So you can write it as 3.33. Okay, so we have 3.33 as option D. Okay, that is your answer for the question. Okay, let's move forward again. Yeah, so they are saying the vapor density of N2O4 in N2O4, which is decomposing to give 2NO2, is 40. So what is this vapor density? So the vapor density in the dissociation, we got it as 40. Okay, now they are asking degree of dissociation. See, it's very simple. Write the equation. N2O4 gives rise to 2NO2, right? So here at initially we have 1 mole of N2O4, here it is 0. So at equilibrium we are going to get 1 minus alpha, this as alpha. Okay, so the total number of moles here I can say simply as 1 minus alpha plus alpha. How much it is? 1. Okay, we are going to get 2 alpha, this is. Okay, so because coefficient is how much? 2, that's why I am writing 2. So what is the formula here to be used for degree of dissociation? Yeah, you just use this. There is a relation between degree of dissociation with vapor density. So alpha is equals to capital D minus small d. So this is n minus 1 d. Okay, like this we need to consider. Okay, so now here you can see now how many moles we got here? 2 moles now. So n is 2. So alpha, degree of dissociation, n is 2 here. 2 minus 1 d, capital D minus small d. So what is this capital D and small d is saying here? See, this small d says about degree of dissociation, the density, vapor density after undergoing dissociation. Like see, some alpha amount is dissociated now. So at this condition, the degree of vapor density of the mixture will be 40. Now what about this capital D? This is the relative vapor density or vapor density at initial, at time t0, whatever the vapor density is exhibited, that is indicated with capital D. See, at t0 we have only N2O4 and 0 NO2 now. So it means whatever the vapor density is there, that is exhibited by N2O4 only. So now vapor density formula can be equals to molecular weight of that substance divided by 2. So why here 2? See, vapor density or relative vapor density, it means we are calculating related to the hydrogen. So molecular weight of that N2O4 divided by 2, because hydrogen molecular weight is 2. Okay. Now for N2O4, 28 plus 64. 28 plus 64. How much it is? Okay, 92. So here you can take 92 by 2. So it is 46. So capital D is 46 and small d is how much they are saying? It is 40. Okay. So divided by 2 minus 1 is 1 here and here 40 here. So you got 6 by 40. 6 by 40. So it means simply you can write, okay. So 6 by 4 we have now. So this will be 1 okay. 2 is remaining, so 5 So 0.15 will be your perfect answer for the discussion. So we have option D as our answer for the question. Hope this is clear now. Yeah, if it is clear, please tell me clear in the chat box. Yeah, let's move forward. Look at this question. Again, this is purely mole concept based question. Yeah, tell me what is your answer for this? 16 grams of methane means what you can say? 16 grams of methane means, so it can be 16 by molar mass of methane is also 16. So you can say 1 mole of that substance. So 1 mole of that substance have Avogadro number of mass, okay, Avogadro number of methane molecules, okay, that is not there, okay. So let's go through the other things also. See, 1 mole of N2 weights how much? 1 mole of nitrogen, that is 28 grams now. N2 means, yeah, so C1, okay. And next one, here 0.5 mole of SO2. See, if I say SO2, 1 mole SO2, it is 32 plus 32, 64. Okay, 64 is the molar mass of SO2. It means for 1 mole it is 64. If I take half mole it is 32 right now. So D will be 3, D3. Now you can see this half gram, 1 gram of H2. See, 1 mole of H2 if I say 1 mole of H2 if I say it is 2 grams right now. So if I say only 1 gram, I am dividing this with 2. It means it becomes half mole. So 1 mole occupies 22.4 liter, but half mole occupies 11.2 liters only. Okay. So 1 gram of H2 occupies 11.4 liters here it is given. Okay. B4. The next what we are remaining with? So this one is nothing but 16 grams. See, 16 grams means 1 mole. It should have Avogadro number 6.02 into 10 power 23 methane molecules. Okay, in one methane molecules how many electrons are there? Check. Carbon atom, atomic number 6 means 6 electrons. Hydrogen atoms are 4. 4 into each one electron, one hydrogen atom, 1 electron. So total 10 electrons. It means Avogadro number into 10 electrons, because in one methane molecule we have 10 electrons. So 1 mole of methane contains 6.02 into 10 power 24 electrons, or you can say 60.2 into 10 power 23 electrons. Okay, for A it is 2, that's it, we got everything. So A2, 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 okay, and B3 here, B4 here, B4 here. Next C1, C1 here, and D3 here. So option 2 is your answer for the discussion. Okay, hope this is also clear. Guys, is this clear or not? Clear. Next. Yeah, can you answer me this? How can we do this? For the following reaction, the mass of water produced from 445 grams of the given substrate. The mass of water produced from 445 grams of given substrate. See, the equation looks very big, but you can solve this very easily. See, mass of water produced. See, now as per this balanced equation, so 2 moles of the starting material, this big molecule producing 110 moles of water, 110 moles of water. Okay, now they are saying the given weight of the substance as 445. This is the given weight. Number of moles formula is what? Given weight by its molar mass. So now just calculate the molar mass of that substance. So that gives you some moles here. Okay, that is nothing but x moles, or I can write weight of that substance by water, that is 18 molar mass. That's it. So this is what we need to calculate now. Okay, just use unitary method here also, it is very easy. First of all, we need to know what is the molar mass of this substance. C57 H110. So this molar mass will be like around 890. Okay, what is the molar mass you are going to get here? 890. That's it. Okay, so from here you are going to get 1 by 2 moles. Okay, so it's easy now. Just see what I am doing. Use the unitary method. 2 into weight of water by molar mass of water. This is 1 by 2 into 110. That's it. So this is 55. Okay, this is 9. Okay, now what is the weight of the substance? Weight is equals to 9 into 55. What is the weight of water formed? 9 into 55 grams. Okay, so just substitute, solve this. 4 9s are 45, 495 grams. Okay, how many grams of water produced? 495 grams. Here you have option number 4 as your answer for the discussion. Okay, hope this is clear. Yeah, if this is clear, please mention clear. Let's move forward. Do this once. Give a try. If the concentration of glucose in blood is 0.72 gram per liter, the molarity of glucose in the blood is, see, whenever it is expressed as gram per liter, this is called strength of solution. What is the strength of solution? See, this is one of the important term. Most of the students will skip this term, but nowadays examiner is focusing questions on the strength of solution mostly from concentration terms. Okay, now we have molarity now. What is the units for molarity? Molarity is nothing but mole per liter. Okay, mole per liter. So what makes the difference from strength of solution from here to there? It is gram per liter, that is mole per liter. So here I can simply say, I can simply convert given weight into molar, like number of moles, by dividing the substance with its molar mass right now, because number of moles is given weight, that is in grams, divided by its molar mass or molecular weight, that is gram per mole. So gram cancel, you are going to get mole as your answer. Okay, so it means if you divide strength of solution with the molar mass, you are going to get molarity, capital M, right now. So now what is the strength of solution mentioned here? It is 0.72 gram per liter. Now what is the molar mass of glucose? It is 180, right? So 180, that's it. Upon this is gram per mole now. So upon simplifying, you are going to get this as, so you can write simply it as 72 into 10 power minus 2 by 180. Okay, this is tenza. So this is 18 forza. Okay, you are going to get 4 into 10 power minus 3 as your answer for the discussion. Okay, so here already minus 3 molar is mentioned. So here you can write just as 4 as your answer. 4 into 10 power minus 3 is the answer for this question. Hope the discussion is clear. Guys, is there any confusion in understanding this? No, right? Yeah. Next question here. Just try to solve this question. Consider the complete combustion of butane. Amount of butane utilized to produce 72 grams of water. See, what is the formula of butane first? C4H2N plus 2, that is H10. Okay, upon combustion, for combustion what we require? Oxygen. Okay, we are going to produce CO2 plus H2O. Okay, how many carbons are there? 4. So 4 CO2. How many hydrogens are there? 10. So here 5 H2. Okay, 5 2s are 10. This is fine. Okay, now how many moles of oxygen is required also they may ask. So it's very simple. 4 2s are 8 plus 5. Okay, 5 plus 8. Total how much? 13 hydrogens are required here. Hydrogen atoms are there that side, so here it should be 13 by 2. Okay, since they are not asking here in the question for oxygen, no need of worrying about that. Just I am saying you to balance that equation. Okay, right. So just check carbons are balanced, oxygen, water molecules are also, hydrogens are also balanced. Okay, consider the complete combustion of butane. The amount of butane utilized to produce 72 grams of water. See, 1 mole of this substance producing 5 moles of water. Okay, so 1 mole of this substance weight is how much? So it is 4 into 12 plus 10 into 1. Okay, it will be 42, 4 to 8, 48 plus 10, 58 grams producing 5 into 18, that is 90 gram of water. Okay, so they have mentioned what is the quantity of butane utilized to produce 72 grams only. Okay, I want only 72 grams. So here what is the grams of butane I used? That is what they are asking. Okay, so now just use the unitary method again. X into 90 is equals to 58 into 72. So 9 5s are 18 5s are 18 4s are. Okay, so that's it. You can write this as 58 into 4 by 5. Okay, so just simply you can take here it as so just take here it as 2 and 2, so it becomes 58 into 8 by 10, so 5.8. so simply you can take it as 4 6 46. Okay, how much it is? 40 plus 6 46. Okay, so one decimal, 46.4 grams. How many grams of butane used here? 46.4 grams of butane is used. See, if I use 58 grams, I am getting 90. If I use only 46.4, yeah, we will get our desired 72 grams of water. Okay, so this is how you need to solve the question. See, it's a numerical type of question in the JEE mains. So they are asking you to give exact number instead of writing 46.4. Yeah, so we can write this number as 464 into 10 power minus 1, right? So what is the answer for this question? 464 is your answer for the discussion. Okay, is this clear, guys? Right, let's move forward. Yeah, can you try this question? Can you try this? Again, this is from JEE mains only. So benzene is nitrated. Upon nitration of benzene, we will get nitrobenzene. In the above reaction, so what is converted? Benzene converted into nitrobenzene, like this. Okay, so 1 mole of this compound forms 1 mole of the product, nitrobenzene, right? So 1 mole of benzene weight is 78. Okay, like C6H6 now. So 6 into 12 for carbon and 6 hydrogen. So it is 72 plus 6, 78. Okay, what is the molar mass of benzene? 78. Now similarly, what is the molar mass of nitrobenzene? So it's again simple. So C6H5NO2. This is what nitrobenzene. So 6 means 72 plus 5, 78, 77 here, plus nitrogen 14 plus oxygen 32. Okay, so how much it is? 77, 87, 91. Okay, 77, 14 plus 32. So how much it is? 6, 13. Okay, so 10, 12, 123 grams. So 78 grams is giving 123 grams of product. Okay, so now what they are asking, see, if it is a 100% yield, 78 grams of benzene gives you 123 grams of nitrobenzene. Now they are asking the above reaction, 3.9 grams of benzene. So it is just 3.9 grams of benzene. Okay, on nitration gives you 4.92 grams of nitrobenzene. So what is the percentage yield of this nitrobenzene they are asking? Okay, what is the percentage yield of nitrobenzene they are asking. See, if I should take 78 grams, I am going to get 123 grams. If I only take 39 grams, what is the theoretical yield of this reaction I should calculate first. Okay, so now X can be 123 into 3.9 divided by 78. Okay, so I can write this as 12.3, 39 2s are 78. Okay, and this can be now 6.15. Okay, so what is this? The theoretical yield is 6.15 grams. Okay, this is the theoretical yield as per the balanced chemical equation. Okay, but experimentally how many grams of nitrobenzene is produced? 4.92 right now. So it means always remember theoretical calculated yield will be more when you compare with the experimental yield. Okay, because during the experiment some compound might be forming as a byproduct. Okay, it will be like 100% efficient won't be there now. So that's what. So theoretical yield will be always greater than the experimental yield. Now they are asking about percentage yield here now. So percentage yield means what you can say? Theoretical yield in the denominator, that is bigger value. Okay, and 4.92 here. Okay, into 100. Okay, so upon simplifying this you are going to get around 80%. So this is the percentage yield of this reaction. Okay, right. Let's move forward with one more question. Okay, tell me what they are saying. Assertion here, a reactant that is entirely consumed when a reaction goes to completion is known as limiting reactant. Will it be correct or not? Yeah. So during a chemical reaction, limiting reagent will be 100% consumed. Okay, excess reagent will remains excess. Okay. Now see, the amount of reactant limits the amount of product formed. Yeah. So whatever the limiting reagent is there, that is in lesser quantity right now. So that will decide the amount of product formed. Okay. Always your calculation, the amount of product formed depends upon the limiting reagent only. So it means assertion is correct, reason is also correct. Both statements are correct. Okay. Both statements are correct. So first option is your answer for the discussion. Okay. Next. So can you solve this question? What is the molarity of solution containing 2.8 gram percentage weight by volume percentage of solution of KOH? So how can we do this? Tell me. Weight by volume percentage, they are asking molarity. So molarity formula, what we have? Weight of that substance by molar mass of that substance into 1000 by volume of solution in ml. Okay, see, if they mention something like weight by volume percentage, that much weight of substance present in 100 grams of solution. What is the weight they mentioned? So 2.8 grams of this substance present in volume they mentioned a weight by volume. 100 ml of that solution. So solution volume is how much? 100 ml. That's it. So here I can write weight molarity is equals to weight is how much? 2.8 into 1000 by what is the volume they mentioned? 100, and what is the molar mass of KOH? Okay. So for K it is 39 plus 16 plus hydrogen 1, 40, 56. Okay, it is 56. Okay, so this will be 10. So 10 means 28 it is. 28 by 56 means 1 by 2. So this is 5. Okay, where do we have option? 2 is your answer for the discussion. Okay, right. Anyone in the chat box? Yeah. Next question here. Yeah, so these are the questions for the discussion from mole concept. Okay, and the remaining questions or remaining chapters will be continued in the next session. So please stay connected with our NEET World YouTube channel. If you have any confusion, please write in the chat box. We'll discuss them in the upcoming session. Thanks for watching. Stay connected.